My name is Riaz Khan. I am founder of the CDP Networks. I have 20 years of industry experience in IT, ITS vertical and .com industry. I started my journey with CDP Network in August 2022 here at CDP Networks. We are helping our candidate to get the best certification training in the world. Our aim is to connect our candidate with the best trainer in the world who share the same passion as us. Before we start with our training, I would like my colleague to give you a brief introduction
Good
to
evening,
the CDP.
everyone. Welcome to the world of CDP Networks, where learning meets opportunity and personal growth knows no bounds. Here at CDP Network, we believe in the power of self-driven education, empowering you to take charge of your own learning journey. Through our meticulously crafted courses, we aim to enhance your personal skills, equipping you with the expertise needed for a significant career leap. With a focus on providing you with sufficient knowledge, we ensure that you not only meet but surpass your professional aspirations. Moreover, our commitment extends beyond the classroom, offering additional benefits such as community support and interactive forums, fostering a collaborative environment that propels your success. Join us at CDP Network and let us embark on a transformative learning adventure together. Our trainer for this course on the basics of CCNA is Mr. Praful Mishra, who has a degree in electronics and communication engineering. He is a CCNA and CCNP Cisco instructor. He is a network engineer by profession and has conducted many corporate trainings. Till date, he has trained more than 2,000 professionals successfully. With his vast knowledge of networking, he believes in sharing his knowledge in a way that should benefit his students to succeed in their professional lives. So, without further ado, I would ask Mr. Praful Mishra to continue with his lecture. Thank you.
Hello, everyone. Good evening. Guys, my name is Praful Mishra. I am a network engineer by profession and a Cisco certified trainer by my passion. Teaching is my passion. Just I'm going to tell you why. See, I completed my graduation in 2018 with electronics and communication stream. Then I started working in one networking company in Israel telecom company as a network engineer. Without knowing what is CCNA, CCNP or these things, I worked there for 2 years, right, on the basis of practical knowledge. Only, like knowledge of installing devices, configuring devices, sometimes changing hardware, putting cable, this type of work. Then I decided to learn CCNA, CCNP, and CCIE. Right? I decided to be master in networking domain. So I learned these all CCNA, CCNP, CCIE from one institute after 2 years of my job in networking company. And I did certification also like CCNA certification, CCNP certification, CCNA security certification, CCNP service provider certification. I did this all certification. And after 1 year of this certification, I started getting exponential benefit because of CCNA certification. Because of CCNA certification in my life, I really, guys, still I am getting exponential benefit because of CCNA. So CCNA is very, very valuable, right? For all network engineer, not only network engineer, software engineer also, to anyone who want to enter in IT industry. CCNA is foundation, entry level gate. So if you want to enter in IT industry, doesn't matter in which field or in which, technology you want to work. You want to work on infrastructure, cloud, server, doesn't matter where you want to work. CCNA is required everywhere. Everywhere CCNA certification, knowledge of CCNA is going to help you. At every step in your IT industry, CCNA will help you, right? So that's why when I started getting this benefit in IT industry, I decided to teach people online, right? And why I am teaching online? Because why we have social media? Social media is for two use. One, to find people who have achieved what you want to achieve. Social media is to connect people, right? We are connected through social media. So here we can find those people who have achieved what I want to achieve in my life. Getting my point? Like if I want to achieve CCNA certification, so I need to talk to those people who have already certified, who have already achieved this goal. So it is very easy on social media to find any type of people. And once you will find this type of people, like people who achieved what you want to achieve, say, hello, can you help me to reach there? I also want to reach there. And second use is find, lower people who want to achieve what you have achieved in your life. Yes, definitely everyone in life have achieved something. So there are some people who want to achieve that also. It's your responsibility to help them. Like what I am doing right now, I know CCNA, right? I know I can teach CCNA to anyone, fine, with real-time experience. So I am searching people who want to achieve this, what I have achieved in my life, and then I am ready to teach them. So if you are among those people, right, who want to achieve what I have achieved in my life, guys, here I am to put my 100% effort to make you understand what is CCNA and why you need to do it, and after doing it, how you can get exponential benefit from this certification. And it will take, max to max 2 to 3 months. Within 2 to 3 months, you can be a master in networking domain by learning this small certification like CCNA and CCNP. So CCNA is first step. Even you want to do higher certification of Cisco, then first is CCNA and CCNA is recommended. If you want to go for CCNP certification, so first you should go for CCNA, then CCNP, because CCNA is associate level certification. See, CCNA, Cisco Certified Network Associate, entry level certification. After doing this certification, you will work for a company for 1.5 hours. Then you will go for other certification like CCNP or for CCNA security. For any other, you can go for cyber security, you can go for cloud, you can go for AWS server, anywhere, right? After CCNA, you have lots of options. But common process is that best is after CCNA, you should go for CCNP, right? So CCNA will take you 2 months. After 2 months, you can, pass CCNA exam. Then you, after again, you have 2 options. One, you can join industry. You can start working there as a network engineer, as a junior network engineer. You will learn there what is the actual fundamental in the real time. Whatever theory part here you will learn in this course, right? Same thing you need to apply in real time. And that's why we are doing it. Why? Because already there are lots of companies who is using devices of Cisco. So there are very limited number of people know how to manage Cisco devices, how to configure it, how to install it, how to power it, how to troubleshoot it. Getting my point? So all companies need what? Engineers. They can work on their devices. They can take care of health of their devices. And you all can be a junior network engineer just after 2 months. So now I would like to start my training, right? It was a really long introduction, but still, first of all, I want to ask you a question. I know there are many people, so it is not possible to answer everyone, but still I am allowing you guys for 5 to 10 minutes. If anyone want to speak anything or want to ask anything to me, you are allowed to speak.
Hello.
Yes.
Hi, my name is Ramya Bhuminathan.
Okay.
Actually, I'm very interested in the networks, so I just joined in this course. So I want, actually, I'm MCA graduate in 2016. So use this course once after I completions. Do you provide job assistance for related about this course?
See, in this course, I am going to cover not entire syllabus. This is free, okay? But here I am to make you understand the concepts of CCNA. Like I will cover all critical topics. This is for learning purpose, only learning purpose. And regarding job also, you can talk to CDP Network. definitely they will help you, right? I'm not promising you, but they will help you to find job. And it depends on location also. Where are you from, by the way?
I am from South India,
Okay, so like Bangalore location is preferable for you?
Chennai.
Chennai, right? So this type of issue sometimes we need to face because of location, because of knowledge, because of field. So if you will have, entire knowledge of CCNA, then definitely we will help you to get job in Chennai location or in Bangalore location, definitely. But we cannot promise you. We are just providing you a great knowledge at free of cost.
Okay, thank you.
Anything else? Anyone?
Yeah, hello. Hello. My name is Stanley.
Hi.
One by one, please.
Hello,
Yes.
my name is Renjo.
Yes, Surindo.
Thank you for joining this group. This group is, I think, this is the greatest group for teaching any of network-related courses, any certification of CCN and other certification which is related to IT profession. But now I see this group recently. Soon I joined to this group to learn a lot of things. I want to ask that can you provide this remotely job for us to upgrade ourselves in IT assistance course, in IT professional course?
Okay, what we can do, we have one WhatsApp group, brother, for that. There we can talk about regarding these things. We have one WhatsApp group.
Yes.
We can talk
I have
there
a WhatsApp group.
regarding it.
I'm not WhatsApp group, but I am following on a course which is listed on WhatsApp group. I see a lot of course. I am learning on those course, but I want now just to assist me to find a job, especially on network related course to teach me and to assist me to find
basic
to get
networking? Basic
Yes.
networking?
Yes.
Like if I will ask you what is the LSA 5 in OSI model, you know this?
Yes.
Yeah, tell me then.
Yes. Hello.
What is LSA 5 in OSPF?
Hello.
You don't know now? So, okay, we will talk about this in class now. I should start training because there are lots of people. It's not possible to talk one by one to everyone, right? So what I am going to do now, I'm going to share my screen and let me show you what is the topic for today.
Sir, I have one question.
Yes.
I'm Vikram Shah from Kolkata location. Okay.
Okay.
Okay, sir. How many days of training class?
It will be 8 days.
8.
16 hours.
Oh, 16 hours. Okay, sir. Thank you.
So is my screen visible? CDP?
Continuous 8 days or weekends?
Weekends.
Yes, it's visual.
Tomorrow is Diwali, so tomorrow will be off. Again, we will meet next week, Saturday and Sunday.
Is this which kind of certification is this?
Is it so?
CCNA certification.
Like Cisco certificate, or you can
Yes.
provide the certificate?
We will provide, training completion certificate.
Okay.
Hello, sir.
Hello.
Hello.
Hi, this is Sisir.
CDP Network.
Hello.
Is there anyone from CDP Network?
Yeah, I am from Sisir. Hello.
Is my screen visible?
Yeah.
Okay. So, but my screen...
I have a question. Hello.
Yeah.
Sir, I have a question.
Yes, go ahead.
I would like to recording video to prepare myself for future in class. After complete the class, I would like to refresh
Recording will be
this
available.
available. Where I found it?
Yeah, we will share these details on WhatsApp. Is there anyone from CDP? Actually, I am just a trainer on CDP, right? These guys are managing those things.
Yeah.
Okay. So first we will start from Very
CDP,
basic.
they cover only CCNA and CCNP, or they have a
No,
CCI?
they have many more courses.
All right.
For CCNA. Fine. So now my first topic is what is a network. So guys, network is what? Network means connecting devices. Connection of two or more devices is called network. Or here definition can be a group of, a computer network is group of computers which are connected together so that they can share information. So this point is very important, so that they can share information. Like if we are connecting to computer, it doesn't mean it is a network, because maybe the machine don't have IP address or this machine don't have IP address. Because of that, they cannot communicate with each other. So until and unless connection is fine, after that communication should be there. Devices should be able to communicate with each other. That is called network. So a smallest network can be network of two computer. This is the world smallest network. Or connecting to any networking device. To any networking device. Like it can be mobile. This is also one network. Connecting, let's say, car with car remote through Wi-Fi. Both will have IP address. This is also one network. So connecting two or more devices so that they can communicate with each other is called network, right? Network can be, let me do one thing here. Let's say here I have two computers. I need to connect these two computers together. What I can do, I can connect these two computers together through one Ethernet cable. Through one Ethernet cable, let's say this is computer 1, C1, and this is C2. This is one network, a small network, right? A small network. Now, if I need to connect three computers together, let's say computer 1 is here, computer 2 is here, and computer third is here. I need to connect these three computers together. This time I have problem. Why? Why we have problem here? See guys, problem is what? Problem is, in this scenario, both PC will have one NIC card. We connect computer through NIC card. If you don't know what is NIC card, let me show you here. See, this is NIC card like this. In all laptops, computers, you will see this motherboard. Inside this motherboard, we have one port. I'm talking about this port, guys. This port. This port is called NIC port. And your one laptop have one NIC port, and another laptop have also one NIC port. So if you need to connect these two computers together, you can connect through Ethernet cable, because Ethernet port will fit in this port, and you can connect these two computers together. Fine. But if you have three computers, so now all computers have one NIC, all computers have one NIC card, one NIC here, one NIC here, one NIC here. Now either we can connect these two computers, right? Or I can connect these two computers, or I can connect these two computers. I cannot connect these three computers together. Yes or no? So here, what is solution? solution is we need what? Centralized device, because like this is called in our, home, we have, sometime we need to purchase extension board. Why? Let's say you have 5 mobiles. These are 5 mobiles and you 4 mobiles are there, and you need to charge it. You need to charge it all four mobile, and in your board there are only one slot. There are only one slot. You can put only one charger in the board. Only one charger in the board. So either you can charge this mobile, this mobile, this mobile, this mobile. You cannot charge these 4 mobile together, right? You can charge only one mobile. But what you can do, you can purchase one extension board from the market where we will have multiple slots, multiple ports, and we can connect this extension board to main power from the main slot. And now we can connect all mobile together. In the same way, here, if we want to connect 3 computers, more than 2 computers together, we need to purchase one centralized device. And that centralized device is called switch. That centralized device is called switch. And switch is the first device that you need to learn in CCNA in detail, like how switch work, how switch take forwarding decision, right? Everything about switch, like how to change the password on switch, how to change the operating system on switch, what if operating system will crash. Everything you need to learn about switch in this course. Switch is very important topic in CCNA. Fine. So this is also one network, right? This is also one network. This is world's smallest network, right? This is also one network. So here in this scenario, I want to show you something like how my network looks. So let's say I am going to design one network of home. Let's say my home. In my home, there are some laptop, like my laptop, my brother laptop, 2 laptop are there, and few phones are there, like my dad phone, my wife phones, and let's say 3 phones are there. Fine. And all need internet. All need internet. So we have internet connection from the Airtel. So here we have one actually what broadband router. Broadband router. Here we have, I have one broadband router at my home, and this broadband router work wirelessly also and wired also, like it is transmitting signal also. So these all devices are connected through this router through wireless. And this is broadband router. And this broadband router is, guys, see, acting as switch also, because it is also connecting multiple end devices. As I told you, to connect multiple, more than 2 end devices, we need centralized device. To connect more than 3 devices, more than 2 devices, 2 computers together, we need a centralized device. Like to connect 3 computers, we need one centralized device. And that centralized device we are using nowadays is switch. So this router is acting as switch also, and it is a router also. Now, what is router? We will see what is router, why we use it. Router is whenever you want to access internet, router is required. Router is required. Router is used to connect 2 different network together. Like, this machine cannot access internet. This machine cannot use internet now because this router is not connected with internet. So here we have actually internet. Let's say this is internet, and on internet, this is internet, and on internet we have multiple servers like Google, Yahoo, right? XYZ. There are lots of servers. So this router is connected with ISP now, internet, right? And now this user can access internet. So this router is doing what? This router is actually connecting 2 networks. One network of internet and network inside my home. Both are different networks. So this is router and switch, acting as both router and switch. So your broadband is like router and switch. You will see there are some LAN port, There are some LAN port like this. Cisco switch. So see, these all are LAN port. We can connect LAN cable here. These all are LAN port. We can connect LAN cable here. LAN cable is like this RJ45 connector. You will see this connector, this connector to connect devices. This one. This is Ethernet cable. So to form network, what we need? First, networking devices. Then we need some cables, right? Or we can connect device through wirelessly also. Okay. So these are requirement for basic network. This is very basic network. Right? This is how we are using internet. But you will learn lots of things here. Like each machine will have one IP address. Each machine will, this machine have, let's say, IP address 10 dot. Each machine will have one IP address here. Let's say this machine have IP 10.1, this machine have IP 10.2, this machine have IP 10.3, this machine have IP 10.4, this machine have IP 10.5. And who will provide these IP address to machine? Again, see, to identify devices in network, we use two types of addresses. To identify devices in the network, how we identify, people with their name, like that, how we identify devices in network with the help of address, with the help of two types of address. We are also using two types of address. One is logical and one is physical. One is your name and one is physical location on the earth, right? So there are two types of address we are also using, and same machine will also have two types of address. One is physical address, that is the permanent address of machine. Manufacturing company will provide that address. That is MAC address. Who will provide MAC address to computers? Manufacturing company. Where? On the NIC port. Whenever, how we can say how we construct computer. In computer, we need one cabinet, then we need motherboard, their RAM, processor, everything. On motherboard, we will have one port, NIC port. And this NIC port will have one hard-coded address there. Hard-coded address there. You will understand in this course what is MAC address and how, we are using it and how companies are using it. So NIC port will have one hard-coded MAC address. That means your machine, your laptop, your mobile, whatever machines, networking device you are using, all will have NIC port. All will have NIC port, and NIC port will have one MAC address. And again, machine need one more type of address, that is IP address. And network engineer is responsible to provide IP addresses to machine. Network engineer is responsible to provide IP addresses to machine. So who will assign IP addresses to this machine? Who will assign IP addresses to this machine? Network engineer. Or we have one protocol, that is DHCP. So that we also discuss in upcoming day. So here you can see, in my home network, actually we are not assigning the IP address. Automatically, computers are getting IP addresses, right? Like if you will, connect your computer through your Wi-Fi, automatically your machine will get one IP address. So actually this DHCP service is enabled by default on broadband router, DHCP. So this router is acting as DHCP server also. So when we are purchasing router for home, broadband router, so DHCP service is already enabled there, right? Some basic configuration is already there, right? So machine will provide, DHCP server will provide one IP address to all machines. And now these machines have IP address. So this machine can communicate with each other. Like 10.1 can communicate with 10.2, 10.2 can communicate with 10.3, 10.3 can 10.4, like this. And let's say this on the internet, there is one server, Google server. This is Google. And Google is using one IP address, let's say 8.8.8. This is DNS server IP address. Fine. And this machine 10.1.1.1 want to access web page of Google server, let's say. right? So this machine will send request to server. First, this machine will send request to router. Router will forward it to ISP. ISP will forward it to Google server, and then Google server will generate reply to ISP. ISP will forward that reply to this router, and then this router will forward that reply to PC. And this is what you need to learn in this course. In this course, you will learn everything about, here, like how packet forwarding is happening, how this machine will generate request message, at which layer we will machine will generate packet, when I will type www.google.com, which type of packet it will generate, where is DNS, DSCP, everything you are going to learn in this course. After that, not only this, let's say this ISP is connected with one different location. This ISP is connected with a different ISP. This is, let's say, in Delhi, and this is in Bangalore. And in Bangalore, same network, my friend have also same network. My friend have also same network in their home here. Right? They are also connected with ISP. Which ISP? Bangalore ISP. And both ISP are connected with each other. So in this course, you will also learn how 10.1 can communicate with this machine. Let's say this IP address, this machine IP address is 20.1, right? So one friend is in Delhi, one friend is in Bangalore. How they can communicate with each other? How all devices will take forwarding decision? How packet will look like? At which devices, what will be the source IP? What will be the destination IP? What will be the source MAC? What will be the destination MAC? And on ISP router, we will have in ISP network, we will have multiple routers. In ISP network, you will have lots of router like this. So you will also learn routing, like how this one router will receive packet. It will decide that which next hop is best for me. I should forward traffic to this router or this router for Bangalore ISP, right? For the destination network. So how routers are going to take forwarding decision, all the things we are going to cover in this course. So this is all about syllabus, like what we are going to learn in this course. Okay. So if I will write down the syllabus again. So see, first of all, we will learn OSI model. OSI model. Why OSI model? Because OSI model is a process which tells us how data out from a computer and how data enter in a computer. How data out from computer and how data enter from in computer. So we will start from here. Like first we will understand how computer is going to generate the data, how computer is going to out the data from their interface only. After that, we will see how devices like routers, switches will take forwarding decision. But OSI model, in OSI model, we will learn how data out from a computers and how data enter in a computer. Fine. So OSI model have some layers, like 7 layers. We will discuss all layer each by one by one. And at each layer, your devices, networking devices will perform some particular task. And that task is important for you to learn. An interviewer will also ask same question, how to solve that task. Which task will perform at network layer, which task will perform at transport layer. Like this, interviewer can ask you a question. Okay. Now, after OSI model will take, around 2 hours, let's say. Then we will start IP addressing. And subnetting. It will also take 2 hours. Then we will move to packet flow. Packet flow between two computers. After that, we will start routing. In routing, we will see a static routing. We will see dynamic routing. One day static routing, one day dynamic routing. Then in dynamic routing, we have some protocol, one day for RIP, one day for RIP and EIGRP. One day is for OSPF. And then we will start switching module. In switching module, we will have STP, VLANs, Ether channel, HSRP. Okay, so these are the topic which we are going to cover. Okay, so let me do one thing here. Copy it. Okay, now let's start from OSI model. So what is OSI model? What is OSI model? OSI model is an process which tells how data ought from computer, or I can say port, or I can say interface from, let's say, computer, and how data out from computer and how data enter in computer. Fine. It has 7 layers. It has 7 layers. Number 1 is application layer. And I have this PDF also here also. So you can learn about basic networking with this PDF also, guys. I have already shared this PDF with you guys. So you can learn basic things like what is networking, what is network. Networking is nothing but construction of network. Design and construction of network is called networking. Means designing network is networking. Advantage is, speed. Without network, we cannot, exchange information quickly, right? It's take long time. But because of network only, we can exchange information quickly. This is, now I am able to teach you online. You are in different location, I am in different location. Both are connected through what? Network. Through what? Network only. This is network. Then cost effective, reliability, and you will understand these all term in upcoming day, by the way. Okay, so these are advantages. Then types of network. There are actually mainly 2 types of network, LAN and WAN. Technology defined networks is LAN and WAN only. After that, human defined is MAN and type, like MAN and PAN. But technically, so types of network is basically we have 2 types of network. One is LAN and one is WAN. LAN is local area network. WAN is wide area network. LAN is my inside network, my private network, or WAN is public network, ISP network. Fine. Then in the basic, you can learn about components of network, like what are the requirements for to design a network. There should be one sender who will send the information. There should be one receiver who will receive the information. There should be media. Through that, we can, transfer the information. After that, there should be actual data, actual information, and protocol. Protocol means set of rule. There should be one rule in communication. Like here, I am teaching in English. Why? Because most of the people don't know Hindi. So it is one rule for me that if you want to teach everyone, you have to speak English. In the same way, networking also, you will see there are some rules. Like computer have to follow that rule to design one packet. So that is protocol. So these all are components of network. Okay, so protocol is there, and protocol field is very important. That is rule. There should be actual data. There should be one media. There should be media. There should be sender. There should be receiver. Fine. Then types of communication. Most of the already, unicast, multicast, and broadcast. There are 3 types of communication in networking: unicast, multicast, and broadcast. Unicast is nothing but it is an one-to-one communication. One-to-one communication means only one guy can send the information and only one guy can receive the information. Only one guy can send the information, only one guy can receive the information, like this. If I will design one diagram here, let's say this is PC1, this is PC2, both are directly connected. This is sender machine and this is receiver machine. This machine want to send some data, let's say, to this machine, right? This is what? Unicast, because one sender is there and one receiver is there. Fine. If I will talk about multicast, so multicast is one-to-many communication. One-to-many communication means when we have one sender and many receiver, like this. Let's say one computer is here. This computer is connected with one switch. And this switch is connected with lot of other computer 2, 3, 4. And this computer, this is sender, and these are receiver. So this machine want to send some data to all machine. It will send to this machine also, this machine also, this machine also. This is what? Multicast. Multicast means one sender and many receiver. One sender, many receiver. Fine. And let's say here we have one more computer, but sender is not sending data to this computer. That is not in the part of multicast domain. That is not part in the multicast domain. And broadcast, finally last one is broadcast. Broadcast is one to all, means one sender and all receiver. Means let's say this piece switch is connected with 100 number of computers. So when sender machine will send some data to switch, switch will forward to that data to all computer. One copy of data to this computer also, this computer also, this also to all computer. Let's say in a classroom there are 40 students and I am teaching. So I am doing what? I am broadcasting it. I am sender. I am giving the information. Here also I am doing same thing. I am sender and you all guys are what? Receiver. You all are receiver, or you all are receiver in a group. Yes, you all are receiver in a group. That means this is not broadcast. This is multicast. Broadcast means one to all in network. One to all. Fine. So this is a small difference between multicast and broadcast. So in multicast, sender machine, this sender machine can send one copy of data to a multiple computer, like to these 3 computer. In broadcast, it will send data to all computer. Fine. So unicast is one-to-one communication, multicast is one-to-many communication, and broadcast is one-to-all communication. Then we have modes of communication. Modes of communication means you know how we will send the data or how we will receive the data. Fine. So we have 3 modes: simplex mode, half duplex mode, and full duplex mode. In simplex mode, if I will talk about simplex mode, so in this mode of communication, only one device can send the traffic and other device can only receive the traffic. Like keyboard, mouse, radio, television, means device who can either send or receive. Who can either send or receive, cannot do both things. Like television, through television we cannot send something. Through television we can only receive the information, right? We are watching news on television, where we can't transmit the signal from television. So television is what? One kind of receiver device it is. One kind of receiver device it is. It will also only receive the data. It cannot send the data. Fine. Okay. So simplex means device who can only send or receive the data, cannot do same thing at the same time. Then second one is half duplex. In half duplex, a sender machine can send the data as well as receive the data, right? A sender machine can send the data also and can receive the data also, but not at the same instant of time. Not at the same instant of time means a sender machine can either send the data or it can receive the data at a time, right? If machine is sending the data, that means machine cannot receive the data. If machine is receiving the data, that means machine cannot transmit the data. So device who can do both, but not at the same time. So in definition also, you can see in this mode of communication, both device can transmit and receive the data, but not at the same instant of time. An example of half duplex is hub. Hub, you can say Bluetooth also, right? Through Bluetooth also, at the same time, either you can send or you can receive it, right? If you want to send some file from between two mobile, so from one, either you can send or receive at the same time. So Bluetooth is also example of half duplex. And then finally, full duplex. So full duplex is two-way communication at the same time. Half duplex is also two-way communication, but not at the same time. But full duplex is two-way communication at the same time. At the same time, a device can receive the data as well as can transmit the data. That type of device works on full duplex. Works on full duplex. Now, networking devices. These are, basic things. Before OSI model, I am discussing these things. That means you can imagine how basic it is. But still, it is important. That's why I'm talking about these things like networking devices. As I told you, as a network engineer, first device that you need to understand is NIC card, network interface card. Like, what is NIC card? NIC card is used to connect devices, connect networking devices. NIC can be wired also or wireless also. Like through Wi-Fi also you can connect to device, right? Through Wi-Fi also you can connect to device, but still both machines are using what? NIC. That is, both machines have one NIC card, Wi-Fi NIC card, and through that both are connected together. Second device is hub, that is not in use nowadays. Nowadays we are not using this dummy device. Why? First reason is here. In the, I have just given you example in half duplex. Example of hub. If it's work at half duplex, that means, let's say if I have connect two computer together here, switch. Sorry, this is hub. Through hub, then what will happen? This both device cannot receive and send the data at the same time because it is connected through a device who works on half duplex. Means at the same time, PC can either send the data or receive the data. But PC can do both. Because of hub, it can't. Getting my point? So hub is a dummy device. Hub is used to connect multiple computers together, but nowadays we are not using it. We replaced it with switch. Now we are using switch to connect multiple devices together. Earlier we were using hub. No one is going to ask you question from hub also. So hub is networking device which is used to connect multiple computers together. It is a physical layer device. It is a dummy device. Why we call it dummy device? Because hub does not have memory. Let's say here I have connected some computer through hub. PC1, PC2, 3, 2, 4, 5 PC. Fine. And here I have one hub. Through hub, these all PCs are connected like this. So what will happen if, let's say, this machine is computer A This machine is computer B. Computer A want to communicate with computer B. So computer A will send data to hub, and hub don't know anything about source and destination. Then how hub will forward this data to B computer? Hub will do broadcast. It will forward one copy to all computers. Getting my point? And this is how B computer B will get the information of A. But all other PCs also receive that information in the network, yes or no? So this is dummy. That's why we call it dummy device. Here, if we will connect switch instead of hub, then what switch will do? Switch will receive the data from PCA. It will check what is source, what is destination, and then it will forward it to only B computer, not to all computer. So hub cannot perform unicast communication, means one-to-one communication. One-to-one can be done with the help of switch. Fine. So next device is, you can see switch. What is this CBD here on the screen? CDP network. What is this? Okay, switch. Switch is a layer 2 device. See, in OSI model, you will see layer 1, layer 2. So hub works at which layer? Physical layer, means layer 1. And switch works at which layer? Layer 2. This is first difference between hub and switch. Both are used to connect multiple computers together, but there are some different. Like switch have memory, hub don't have memory. It's work at layer 2. Switch works at layer 2. Hub works at layer 1. Switch are used to connect multiple devices in LAN network. Switch works on full duplex. It works on full duplex. Switch can be unicast, can be multicast, can be broadcast a traffic. Switch is an intelligent device. That's why we are using it. Fine. And then router. Router is a layer 3 device in OSI model. Layer 3 device in OSI model. Soon you are going to learn OSI model also. And router works on full duplex. Router works on full duplex, means router can perform both receiving and transmitting at the same time. Router are used to connect two or more different network together. Different network together. Like switch is used to connect what? Different end devices together, computer together, switch. And router is used to connect two different network together. Let's say here we have two network. This is N1, network 1. This is N2, network 2. I want to connect these two network together. I need to use one router here. Fine, like this. So router is a layer 3 device. It's work on full duplex. It is used to connect multiple different network together. Then we have some domain like broadcast domain and collision domain. We will talk about it later. Before that, let's begin OSI model. This is IP addressing. After OSI model, we will come on IP addressing. Then we will talk about memory of routers, content in memory also, booting behavior also. But not now. First, let me cover OSI model. See how to break password OSI model. So OSI stands for Open System Interconnection Model. Open System Interconnection Model. Developed by ISO, International Standard Organization. International Standard Organization. OSI model is developed by this organization, ISO organization, right, in 1980. After OSI model, see why we come up with OSI model. First of all, this is good question. Why we come up with OSI model? See, before OSI model, here let me write the name of other layer also. Application, then presentation, then session, then transport layer, transport, fifth one is network, This is actually third one. This one is 7th layer. Let me correct it. 7, 6, 5, 4, 3, 2 is data link layer. And last, first layer is physical layer. Physical layer. Okay, so these are layers. See, let's say I have two computers. One computer is of Dell and one is of HP. So earlier, before OSI model, Dell computer, this is PC of Dell and this is PC of, let's say, Apple. Nowadays, you are able to see both companies' devices are able to communicate with each other. But earlier, Dell was not able to communicate with Apple devices. Why? Because Dell have used different process to manufacture their device, their NIC port. Their encapsulation process is different from the Apple. Apple have different process, like as I told you, protocol is there, right? One component of network, that is protocol. That there is some rule. So Dell is using different rule, Apple is using different rule, right? Both have different process, so they cannot communicate with each other. So OSI model comes so that different vendor devices can communicate with each other. What OSI model did? OSI model is nothing but a blueprint. It is a blueprint of process. Like ISO tells to all vendor company who is manufacturing computers or networking devices to follow this common process of OSI model. ISO organization tells to all vendor devices to follow OSI model process to manufacture their computer. If you want to connect your computer to internet, then only your computer can communicate with internet. So OSI is also one process of what? Process of communication, process of manufacturing devices, designing hardware, software. This is process of designing hardware and software. Now OSI model have hand over this process, like these all 7-layer tasks to all vendor company. And now Dell will manufacture their computer according to OSI model, and Apple will also manufacture their computer with OSI model. So both computer will have same NIC port, both computer will have same rules, same encapsulation process, same decapsulation process. So now they can communicate with each other. So reason of why we come up with OSI model is very simple, so that different vendor devices can communicate with each other. And same thing here I have mentioned. After OSI model, now different vendor devices are able to communicate with each other. It acts as a blueprint. As I told you, it acts as a blueprint. Fine. In OSI model, we have these 7-layer: application, presentation, session, transport, network, data link, and physical. Now we will learn each layer one by one. See, first, application layer. What is the use of application layer in OSI model? What will happen if there is no application layer in OSI model? User cannot interact with software. Like I want to, let's say, access web page of Google server. So I need one interface. And this is my interface. This is what? One interface to interact with Google server. Here I can type www.google.com or facebook.com. If I want to access any website, I need what? One interface. So this is interface. And this interface is provided by which layer? Application layer. Application layer act as an interface between user and actual application. Actual application is my Google, and I am the user who want to access the web page of Google. So who is going to interact me with the server? Who is going to interact user and actual application? That is called application layer. That is called application layer. So application layer is responsible to act as an interface between user and actual application. This layer tells that application is internet based or not. Definitely, like if you want to share some file from one computer to another computer, both are connected to Ethernet cable. Here internet is not required. So who will tell to machine that when internet is required, when internet is not required? Application layer. Application layer is responsible for these things. If we are transferring one file through FTP server, through file transfer server, then it is not internet based communication. But if I am accessing Facebook server, this is internet based communication. So application layer will tell that which application is internet based or which one is not. After that, there are various services like web service, file service, remote access service, time service, mail service, etc. are used at this layer, right? So these all services can be accessed by application layer. These all services is accessible by application layer. Okay, now if you want to access web page, to access any services like web page service, file transfer service, if you want to transfer file from one computer to another computer, remote service, time service, any service, if you want to access any service, you need one protocol. Here you can read. These services are accessed with the help of some protocol like HTTP, TFTP, HTTPS, Telnet, SSH, SNMP, SMTP, FTP, DNS, and many more. Who work on this application? App developer. App developer design these protocols, and we need to learn these protocols only, like how these protocols work. We need to learn it, how these protocols work. Fine. So these are the protocol. Through this protocol, what we can do? We can access these services. We can access these all application layer services. Like if you want to access web page, you can use this protocol, HTTP or HTTPS. We have only two protocols to access web page. Let's say in the Google, I'm typing www.facebook.com. See here in the browser, guys, which protocol we are using here? Which protocol we are using here? HTTPS. We are using HTTPS protocol. So HTTP and HTTPS is used to access web page. TFTP is used to transfer file from one computer to another computer. Telnet is used to access devices remotely. Let's say in remote location, we have 100 number of routers. So it is not possible to troubleshoot that 100 number of router on physical location. We need lots of engineer. So what I can do, I can enable Telnet feature on all devices, and I can access these devices remotely to monitor it. Getting my point? So for that, we have this service, Telnet, then SSH, SNMP, FTP, DNS. Now I would like to show you one lab, a small lab of telnet, like how telnet works or HTTP works. So let me do one thing. Let me open my packet tracer here. Packet tracer is simulation software, very good tool to perform basic lab of CCNA. And then we have GNS3 also. After packet tracer, we have GNS3. But packet tracer is good for beginner. GNS3 is for advanced, like for routing concept, for routing protocols, to run OSPF, EIGRP. We will use what? GNS3, and for basic lab, we will use packet tracer. You can simply download it from Google and you can install it in your computer. Like if anyone don't know how to install packet tracer, so let me write down here. See, in the Google, you will type Cisco packet tracer, and on any link you can download this software. This is software. You can see Cisco packet tracer. This is logo. Fine. You can download it here in my computer also. Packet tracer. You can see this is packet tracer. Cisco packet tracer. Fine. Login is required. First time you have to log in it. You need to create one username and password on Cisco website. Then only you can use it. In packet tracer, I am going to design one simple network. Let's say I have some computers. 1, 2, 3. We have 3 computers. Let's say I need to connect these 3 computers. How I will connect? Through one switch. How I will connect it? Through one switch. So here I have switch also in packet tracer. You can watch a small video on YouTube how to use packet tracer. You will get lots of video to use these devices here. Like here I can use this switch to connect these devices. Then I can select cable. I can connect this computer to cable like this. And just give me 1 second. Here I think device name is not showing. So always show port label and device name. Yes, now you can see we are able to see device name. This is switch, this is PC0, this is PC1, PC2. If it is not visible, let me zoom in. Now hope it is visible. Now if this machine need what? First of all, these machine need addresses. 2 types of address, IP address and MAC address. All PC have already MAC address. Let me show you. In interface, you can see this is MAC address of this machine. This is MAC address of this PC. But this machine don't have any IP address. This machine don't have IPv4 address. So either I can give IP address here 10.1.1.1 or any IP address, or I can put one DHCP server here. I can put one DHCP server here. Like here you can see I have server also. I can put one DHCP server. I can configure this DHCP server so that this DHCP server will provide IP addresses to this machine. And DHCP also work at application layer. Let's say this is DHCP server. Fine. 1 second, guys. Yeah. Now, in this scenario, see how we can set up the DHCP server. How we can set up the DHCP server. First of all, DHCP server also need one IP address. So to assign IP address, you will click on the server, then go to desktop, then IP configuration, and here we can assign one IP address. Let's say I'm assigning 192.168.1.1 is the IP address of this machine. And I said subnet mask is 255.255.255.0. If anyone have problem in IP addressing and subnet mask, don't worry, we will discuss it right in separate video. We will have one class, separate class for IP addressing and MAC addressing. So then we will learn it. For now, I have assigned this IP address on this server, and I have defined this subnet mask. Now I need to enable DHCP services here. So we have one services section. In services section, we have DHCP server, and by default, this server is off. This service is turned off here. We can turn it on. And then we can say, we can create one pool. First of all, pool name, let's say pool name is server pool, and then default gateway IP address. If you want, you have default gateway. Soon you will understand default gateway also. Default gateway means gateway of my network. My router IP address is my gateway, like my main door. Okay, so let's say gateway IP address is 192.168.1.100. Fine, then DNS server IP address. We can say DNS server IP address is 8.8.8. Starting IP address 192.168.1.0. Last subnet mask 255.255.255.2. Total number of IP addresses. TFTP IP address. No, everything, leave everything for default, and let me save it. Done. I have enabled the DHCP service here, and I have created the pool also. Now let me try this PC is able to get IP address from DHCP server or not. So to get IP address from DHCP server, you will click on DHCP instead of static. Here, as I told you, we have two options to assign IP addresses on machine. First one is static, second one is DHCP. So this time I am not assigning IP address statically here. I am selecting DHCP service. So see, this machine have got one IP address, that is 192.168.1.2. So machine DHCP server is providing IP address correctly now to this machine, right? First IP address is 1.1, 192.168.1.1. DHCP server is using that IP address, and DHCP server have provide 192.168.1.2 to PC0. And let's say here I have PC1 one have also need PC1 also need one IP v4 address. So here also I am clicking on DHCP, and this machine will get this IP address. See 1.3, 192.168.1.3 is the IP address of this machine, right? Subnet mask 255.255.255.0. Gateway IP address 192.168.1.100. DNS server IP address is 8.8.8.8. So DHCP server is not only providing IP address, it is also providing default gateway. It is also providing DNS server IP addresses, everything. Getting my point? Now, if PC2 will request for IP address, what will happen? PC2 will also get one IP address. PC2 will also get one IP address from DHCP. See here, 192.168.1.4, subnet mask 255.255.255.0. Gateway is 192.168.1.100. DNS server IP address is 8.8.8.8. Correct? Right? So all machine have now IP addresses, and this DNS works at which layer? At application layer. At application layer means at layer 7 in OSI model. Fine. Now this switch is connected with one. Let's say I have one another network here. Here I have one another network, and this side also I have some computers, and let's say some servers are there. Let's say this is web server, Google server. www.google.com. Fine. And let's say this is DNS server or any DHCP server. And I need to connect these two networks together now. What I need? Router. So this time I will select one router here. Let's say this one. And I can connect switch to router and this router to this switch. Now you can see this is one different network. This is one different network. We have two different network here. Right? Now, by default, switches interfaces are up. Interfaces of switches are up. We don't need to configure anything on switch. But to use router, we need to configure something. Like you can see port of router is down. Port of router is down. So here I need to up these interfaces. So I have to access router 0. So let me access R0 here. And now I'm going to configure it. I will configure this router here. No. Enable and see show IP interface brief. We have some interface on this router like fast Ethernet 0/0. Two interface we have fast Ethernet 0/0 and fast Ethernet 0/1 on this router. On both interfaces, we need to configure IP address. So let me configure one IP on fast Ethernet 0/0 first. So interface fast Ethernet 0/0, say no set here. And then we will say IP address 192.168.1.100.255.255.255.0 exit. Then interface fast Ethernet 0/1 no set and IP address. Let's say here is this side I am using 192.168.2.200 2.100.255.255.255.0. And now if you will check IP configuration, so IP interface brief. Now you can see IP address on fast Ethernet 0/0 is 192.168.1.100. State of this interface is now up. Protocol is also up. On this interface also we have one IP address and interface and protocol is up, are up of it, this interface. Fine. Now this is basic configuration of router. Now these PC also need IP addresses. So here manually I am going to assign IP. Let's say manually on this machine I can configure one IP 192.168.22. Let's say 1. Submit mask is this one. Gateway is 192.168.2.100. So here I have assigned the IP address. What? Let me write the IP 192.168.2.1 and this machine IP address is 192.168.1.2. Right. Now can these two computers communicate with each other? PC0 with PC3? Answer is absolutely yes. Because both machines have what? Default gateway IP address. Both machines have their default gateway IP address. Both machines know my default gateway is router. My default gateway IP address is what? Right. So because of that, from PC number 0, if you will ping 192.168. What is the IP address of PC3? 192.168.2.1. 2.1. So you can see ping will work here. Ping is working. I'm getting reply back. And now if you will check ARP table of this PC, ARP, you can see inside the ARP table, this PC have MAC address of their default gateway. As I told you, see, any machine, any two devices want to communicate with each other. So they need source IP, destination IP, source MAC, destination MAC. These four things is required for, these four are basic requirement of communication. Basic requirement of communication. Basic requirement of communication. Source IP, destination IP, source MAC, destination MAC. So when this PC will ping to this PC, PC0 will ping to PC3. PC3 belongs to different network. This machine will add source MAC, destination MAC, source IP, destination IP. So in the packet, if I will show you the packet, here if I will show you the packet, see again I'm going to ping, and see this PC have generated this packet. If you will open this packet, you will read the information. In this packet, if you will read the information, see, let me show you here if it is visible. There is source IP. Source IP is the IP address of PC0. Destination IP is the IP address of PC3. And source MAC is the MAC address of Source MAC is the MAC address of PC 0, sender machine MAC address, and destination MAC address is the MAC address of default gateway. Same MAC address you can see inside the PC 0 ARP table. PC 0 ARP table, you can see the MAC address. This is destination MAC address. In last it is 0, 1. 0, 1. Here also you can see in the last MAC address is 0, 1 in the packet. Means whenever destination belongs to different network, then destination MAC will be MAC address of default gateway. MAC address of default gateway. So what I am saying, that when I will ping this IP address 192, this IP address from this PC will encapsulate one packet, ICMP packet. In the packet, it will add source IP. Source IP will be 192.168.1.2, my IP address. It will put destination IP. Destination IP will be 192.168.2.1. Destination device IP address. Then this machine will put source MAC, destination MAC. Source MAC will be the MAC address of PC0. Let's say PC0 MAC address is 0A. This interface MAC address is 0C. This machine MAC address is 0B, and this interface MAC address is 0D. These are MAC addresses of device. So this machine, when this machine will encapsulate packet, it will add source IP, destination IP, source MAC. Source MAC will be 0A, and destination MAC will be not 0B, 0C, because destination belongs to different network. If destination belongs to same network, if let's say PC1 have IP address 1.3 and PC0 want to communicate with PC1, then destination MAC will be the MAC address of PC1. Then destination MAC will be the MAC address of PC1. But if PC0 want to communicate with PC3, then destination MAC will be the MAC address of default gateway. MAC address of default gateway. Means if destination belongs to different network, then my responsibility at layer 2 is to share data to default gateway. Okay, so this is first learning, guys, for you. Always keep in mind, whenever a computer send data to machine who belongs to same network, then destination MAC will be the MAC address of destination device. That is fine. But if destination belongs to different network, then destination MAC in the packet will be the MAC address of default gateway. Fine. And now let's say on this router, let's say I need to change some configuration. So I have to access this router, right? So I need to arrange one FE field engineer to access, who will, access this router. Then they will give me any disk, and after that I will change the configuration. So no, we have another option. Another option is we can enable remote services. We can enable telnet here, and from this PC also I can access this router. From this PC also I can access this router. For that, just I need to enable telnet service here. Telnet service is by default enable. I need to run one command, line VTY 04. You will learn these things, don't worry. Password, and here we can say no login. Line VTY 04. Let's say password 123, right? And say login. Fine. So I have enabled telnet. This is only command to enable telnet. Now from this PC, see, from this PC, simply I can run this command here, telnet, and then IP address of my router. What is IP address of my router? IP address of my router is, and before that I want to show you packet also. IP address of my router is 192.168.1.100. Once I will hit enter, you can see this machine have generated one packet. This is telnet packet. This is telnet packet destination port is 23. Again, after OSI model, when we will discuss transport layer, I will show you this thing. Okay, but for now, see, this is telnet packet. It will forward it to switch. Switch will forward it to router, and then router will forward. Router will actually check username and password, and after that, it will reply to this PC. And here in the console of this PC, you can see I have, it's asking for password. So password is 123, and now you can see I have access of my router. This is router. This was PC. Now here I can modify the configuration. Let's say I want to change host name, or I want to, it's saying password is not set. So if password is not configured on router, then you cannot use telnet. So let me configure one password here, enable password, let's say 123. And now we can configure it. Password is again 123. And you can see now here I can change the host name. Let's say host name is anything, R1. So now you can see my host name is R1. So this is how we can access the networking devices remotely, and how we can modify the configuration. Okay, so this was a small introduction about OSI model, like why we come up with OSI model. And in next class we will learn all layers of OSI model, all layers of OSI model one by one. That is very important for network engineer. And once you will understand these layers, I will start actual networking. Like first we will discuss packet flow between two computers, how packet will flow between two computers, then packet flow between two computer over switch. We will have one switch between two computer, then packet flow between two computer over router. If we have one router, then how packet will flow, right? And after that we will see routing protocols and these things. Okay, so this is all about today's session, guys. Now we have 15 minutes for Q&A session. If anyone have question, you can ask. This was all about OSI model. Why we come up with OSI model? So that different vendor devices can communicate with each other. Different vendor devices can communicate with each other.